Okay, welcome everyone. We're about to begin a new series of free online workshops about teaching introductory statistics. The title of this series is Student Activities for Exploring Statistical Concepts. My name's Alan Rossman. I teach at Cal Poly in San Luis Obispo, California, where we're on the quarter system and won't begin teaching until Monday, September 23rd. But that fact will not be on the quiz. I doubt if there will even be a quiz. So you can see on the screen, Beth has prepared a slide to tell you what's happening today and what's coming up on the next 4 Fridays, all at the same time, all at 3 o'clock Eastern time, 12 noon here on the West Coast. We'll have 1-hour sessions with different presenters giving you an introduction to a student activity that introduces students to some statistical concept or gives them experience with exploring some statistical concept. Beth Chance is a colleague of mine here at Cal Poly. Beth has been at Cal Poly for many years. She's written textbooks on teaching introductory statistics. She's the driving force behind the so-called Rossman-Chance applets, through which students can explore statistical concepts. And she'll be presenting an activity or two today on the topic of sampling. So let me be quiet and ask Beth to take it over there.
Oh, okay. Thank you, Alan. Thank you all for coming, and thank you for those who have showed your video. It's nice to have at least a few on my screen, so I know I'm talking to live people. And just a little idea of what I want to do today is to have this introduction to sampling. So this is what I do early in the course, and we tried to organize this series of workshops to kind of go in order of the course, but we realized because we're in the quarter system, we're starting a little late for some of you, but hopefully you might catch up and see some activities you could use in your course this term even. And so this is when I introduce the idea of good sampling methods and bad sampling methods, and you'll see that in a little bit. And I'll show you, this happens actually on days 9 through 11 in my course. And I would ask you if you want to go to the EA Post Links website, and maybe we can put that in the chat. You'll see a copy of the PowerPoint, you'll see the handout, you'll see some other things. But I would ask you maybe not to go to the handout quite yet. Another link that's in the PowerPoint is to my course. The last time I taught this intro course for non-majors, mostly social science majors. And it is a 4-day-a-week course right now where I was able to teach it in a traditional classroom and then like a lab classroom, and then alternate that every other day. And so that does kind of impact, or sometimes I have to think really hard what I want to cover on a particular day when I have them in a certain format. And I also wanted to talk a little bit today about some kind of different implementations, some new things I'm going to try, and hopefully we'll have some time for discussion if you want to ask some of your questions on that or share some of your own experiences. And I think there'll be some time at the end to then say, actually, what we do in our curriculum is the very next day, we start talking about inference for one mean. So the sampling's kind of there, fairly traditional, but really to serve the purpose of, I want to get these students fairly quickly to the idea of why we're taking these samples and why we might be looking at quantitative data. And that leads into inference for one mean. And I guess part of my point there is we try and organize the course that we're going to learn this topic because we want to answer a slightly different research question than what we've been able to answer before. So in my course, we've already talked a lot about proportions. And so this is also the transition to quantitative data. So part of the reason I didn't want you to look at the handout yet is I think maybe even earlier in the course, when you're maybe defining observational units and variables with your students and what are quantitative and categorical variables is what I call them, is maybe giving a preview of some of the research questions that they'll see later in the course that do involve maybe just one quantitative variable or one categorical variable. And this idea of thinking about variables and how they're different from research questions, or how you make a measurement testable, or how you can answer a particular question, is not as easy for students as maybe I used to assume. Even these social science students, I'm usually getting them as first year, second year, so they haven't thought a lot about answering research questions or how to state a research question. So I'm going to ask you to take 30 seconds and think about a research question that involves just a single quantitative variable. So go ahead and think for a minute. And, something you think would be interesting, something you wouldn't mind measuring. Sometimes I do this with students as their initial brainstorm for projects I'm going to have them do. Can you think of a couple different variables and we'll decide later which ones we want to analyze. All right, so hopefully I wasn't too distracting, but please go ahead and post your example in the chat. Try and give me some good examples and some bad examples. So gender inequality of what? Like what's the quantitative variable that you're measuring? Sulfur level, thinking about what's the quantitative variable, price of gas, price spent on textbooks, hours of sleep, and thinking of things that might be interesting to your students. These are really good. All right, so those are good quantitative variables, and some of you have started turning these into research questions, and you kind of have to go to an average for that, right? How are you going to summarize that variable? How are you going to test something about that variable? So some of you talked about hours of sleep, so maybe thinking about, well, what is the average hours of sleep? And that's maybe going to be more of a confidence interval type question. But maybe I want to compare the average hours of sleep to 7 or 8. And it's actually maybe not as easy as we would like it to be to think about an interesting research question where you're just comparing a mean to a single number. And so that's another reason why I think this is a good activity, fairly easy, early to do in the course. Another thing you can do is think about something that might lead to comparisons later. Those are a little bit easier to think about, like time spent listening to different candidates, maybe depending on party affiliation, right? But then what would you maybe first ask as just a single variable of one group? What might be an interesting comparison? So I think that's something to maybe do early in the course, and then you can come back to it later in the course. My goals are really just having them practice, thinking about observational unit, variable, types of variables, thinking about genuine research questions, hopefully, sowing the seeds a little bit for some genuine research questions that they'll see later in the course. But it maybe even also defining these ideas of statistics and parameters. Like I'm going to be able to measure the average amount of sleep in my class, and then what's the parameter I might be able to estimate beyond that? Is it just the average at Cal Poly or the average of all Cal Poly or all college students? Right? And I still struggle a little bit in the course of where to introduce statistics and parameter. I tried to put it off a little bit, but then I found they really needed it. And so I wanted to start it earlier just to give them lots of practice with it. And maybe doing it first in terms of these words and these definitions and not even introducing any symbols for a little while might be a place to do it. And then I just also think if this helps you understand what topics students might find interesting, hopefully increases their engagement, maybe even gives them some ownership of the research questions that you'll look at later in the course. So as I say, I want to focus on today on an activity about sampling words. Students in my class have already discussed inference for one proportion, both simulation-based and theory-based. So this is already a few weeks into my term, and we've done everything in terms of one proportion all the way through confidence intervals, and even a little bit on power and so on. And then I'm going to try this a new way with you all, and you can give me some feedback on how it works. And I'm going to see if I can put this link in the chat as well. Where it gives you a set of words, and the instruction I give to my students is to quickly select 10 representative words. And you can do that in this web page by just clicking on words. And it even keeps track of how many you've clicked on. I do try and hurry my students along a little bit. I don't want them to think too hard about that. I don't want them to read and try and understand and try and get at the sense. I think you could replace this with just pick 10 random words, and I think it's still going to work. A lot of my students complain, well, what do you mean by representative? I actually want them to self-define that at first. And then we come back and talk about what that means. And, does it matter what that meant? So can I talk and click at the same time? All right, once you have 10, then the submit button should light up. And then you can enter the average word length. So this would take a couple minutes. Maybe I'll talk slower and give you all time to try and figure out your average. And I'm going to want you to put that number in there. Is it worth spending this time in class? I think so. Again, this is my first real introduction to kind of sampling from a population, and I want it to be as concrete as possible for the students. I want them involved in that process as much as possible. And again, that idea of taking a variable and converting it to a statistic to a single number, I think is a valuable contribution. So instead of you having typing this into the chat like we used to do, you can type it in here and that's going to gather the data for me. I cheat since I've been using this for a couple days. I just put in a number and it tells me I got it wrong, but at least gives me the word lengths. So you can do a little bit of time savings there if you want. I don't know if I can do this. 3.6 and 9 is 4.2. Just goes, that's one reason we like 10, is it should make it a little bit easier for them to calculate the average. And then you can enter your name here and you can select an instructor. You should be able to select Chance, and I'll talk a little bit about this in the future in a little bit. And then you can submit your results. And it lets you know, it does take a couple minutes to submit, but once you submit, it gives you some links. One is to see the results just for that instructor. So we could set this up. If you just want to do it for your students, only see your students, you can now see those. You can even send them directly into an applet. And so this is a descriptive statistics applet, that particular one. And then I can press use data. And this is what, well, it's what you all have been entering, but it's also what I did when I was playing with it a little bit. So it's not the best idea. So all these that are kind of integers are probably me playing with it. I can go in and kind of get rid of some of those. In fact, I can get rid of a lot of these things. You also have access to the spreadsheet. Today's the 13th, right? So let me see if I can delete a bunch of these. This is a fairly new tool, so we'll see how well it's working. And I think I need to go back up, maybe not. Yeah, the other one I did, there's a way to cheat and get directly to those links. You can hit enter to get that, and then I have to do this again, 27, 31, 36. Not right. All right. Let me go ahead and just enter this again, and maybe I'll get different results this time. All right, yeah, that's fairly typical for what I typically see with my students. I did go ahead and label this average. It does give a little bit of a check if you're worried about, well, students may not calculate those averages correctly. That's not the most important thing here. This is not the genuine research study. The main thing I want to get out of this is I want each student to realize they're one of those dots, right? And we can start saying, who is this that got so low, and they can talk about how they did that or anything they might have done differently. Try and make people with really big averages realize that's not that unusual. You're not alone, right? Some people are getting really big averages. I want them to be one of those dots. And so when we come back later and talk about this distribution, hopefully it's a little bit, again, more concrete for them. And they understand what they would need to do to add more observations to that distribution. And I can ask things like, well, how unusual is it to get 4? And like only 2 of us got 4 or less or something like that. And I just want to give them that ownership of the experience. So maybe now, there's a couple other of these that I've been playing with where it makes it easier just to kind of collect student data. And that's one thing I've been trying to do more recently in my courses is collect data on them. Again, it's not going to be a real research study. We'll talk about some of the problems with just using data on them and generalizing to different populations. But when you want to have them compare the data that was observed to the data that was simulated, I think it's a lot easier when they actually did observe that data, when they can say, we did this, and it makes it a little bit more concrete for them. So we have this memory test. This is really for comparing 2 groups. But again, we've set it up where you can create a link that's specific to you. And if you give that link to students, then your instructor name will automatically populate on that page. And when you look at the results, it'll just be for your students. And you don't have to, scroll through the Google Sheet or sort that. And there's another one that I just started using last year that I actually stole from somebody at in CSU Sacramento that is just a little survey on water usage. So again, it's not a great match to college students, but it asks things like how long do you take showers? How many times do you do laundry? And this might be, again, a nice quantitative variable. This one, they kind of have to get a number and then they submit that number in Canvas or something like that. But then we can come back and do a confidence interval or ask one thing to change and do a pair t-test on the difference, how much they're able to save by just making one little change, things like that. So feel free to reach out to me if you want to use any of these ways of collecting data a little bit more. So this is normally what I would do in the classroom. You know, these are the slides I'm using in the classroom. Oftentimes they come back and say, well, if I knew you were going to look at the number of letters in each word, I would have done a better job. I'm like, well, it shouldn't matter what I decide to measure. Maybe I wanted to measure nouns versus non-nouns, or whether or not it had the letter E. Any sample should be representative or give me a mini picture of the population, no matter what variable we end up measuring. And it might even be worth thinking about some variables that might be less biased than others, things like that. They calculate the mean. I show them a dot plot of results. This is me trying to, as I know this is blurry, but maybe illustrating that process for them. So I'm finding that web page maybe a little bit better. And then something else I would have asked them pretty early is were those good samples? Did we do a good job? And I want them to realize pretty quickly, like, I don't know if we did a good job because I don't know the right answer in this case. But because I did have access to the Gettysburg Address, I do know the right answer. So then I tell them the mean of all 268 words in that Gettysburg Address was 4.295. And then now I go back and say, how did we do? Was this a good sampling method? And again, being very careful to put all the blame on me, giving bad instructions, rushing them, but hopefully also convincing them that human judgment is generally not a good way to select a sample. And in fact, I'm wondering if this web page will make it even easier for them to just kind of go around randomly on the page, right? And just pick kind of a little bit from each or something and realize that's not going to be that much better, right? So we're seeing this tendency. And I think what comes next is, this is actually from a workshop, that's Alan's handwriting, right? So very typical of what you might see, this tendency for these averages to be too large. We may get a few that are low, and we know we're not going to hit 4.29 or 4.3 exactly. We would like to at least be centered around that 4.2, 4.3. And we talk in class about why do you think there is this tendency to be too large? And again, because students have participated in the experience themselves, they can usually come up with some very good answers as far as, well, I was looking for words that captured the meaning of the passage, or just those big words stand out a little bit more and I missed a lot of the small words. So I didn't think the small words were very important. And it was just hard for me to see them. And so then going back and asking them, well, if you were just blindly picking, right, either on a page or on that web page, would that be any better because you weren't looking at the meaning of the words? And hopefully they realize, no, that the longer words are still going to take up more space on the page. And so that's going to, again, give us that tendency to select the longer words. And so then, I don't know, any questions on that before we go on? Well, maybe what I want to do now is actually, if we go back to that EA Post website, and actually I think I'm going to cheat and go to having it open here. Or not. I don't have it open. Yes, I do. Kind of. Here is what I put together recently as a way to have students, instead of using the handout, go through this. Think of this as a Google form. It's called a Jot form. It's just a Google form on steroids. And so here's a link to that word sampling app. You can make the names in the email required. I don't do that while I'm testing it just because I get too lazy and I just want to be able to go to the next page. And you also have these tabs across the top to go to the next page. So this is just another way to kind of go through that. So originally they were just going to write their words here, and then if they did that, if they did write their words here, then they would appear on the next page. So one thing that I've been trying to think hard about is I want these pages to be kind of small and digestible, but I don't want them to have to go back and forth a lot. So I try and carry over information as much as possible, or I make them into a response before I give them, you know, feedback or a definition. And again, you'll see some definitions, but they're still in this context of how do I estimate the average length of words. And there was a little bit at the very beginning on, you know, there is this field called literary computing where they're trying to look at characteristics of people writing to decide authorship, or to compare, again, different political candidates and their State of the Union addresses or things like that. How do we characterize these different passages? So I'm trying to keep it realistic that way, or go back to, you wanted to know something about average amount of sleep of Cal Poly students. So we need to know how averages behave. We need to know if averages are going to get us close to the right answer. And we can see that that's going to depend on how carefully we select that sample. Right? This one I don't think checks your mean, so I'm just going to enter a number. Right. But again, that's now stored. It's stored like in a spreadsheet for me, so I can go back and just access that if I want everybody's answers. Now I give them the definitions. These are links. So try and make sure that there's some built-in support if they want to go see some additional definitions. But then these are where maybe in that lab environment, I'm having them work together with a partner, and they're just typing in these answers, and they're going to submit this, and that's what I'm going to grade them on. Maybe not all the questions, maybe just some of the questions at the end, but I do like that ability to force them to kind of write out their thinking a little bit and know that I'm going to see that. And it does populate that spreadsheet live, so I can see that coming in as students are typing in answers. And I don't know if nobody's submitted yet, but this is kind of what that spreadsheet might look like. And I'll talk about kind of grading their answers in a minute as well. But here's a case where I had to give them just some previous results. I think that's a major weakness of this particular activity. Again, I can't emphasize enough that I think them having to come to the board, or at least type it in and see their results and be able to identify themselves, is a critical part of this activity. I think this just, oh, here's what somebody else got, would not be nearly as good if you can collect that data. But now there's ways to collect that data outside of class and you haven't taken any class time, and they still have that ownership. And then also trying to let them know this is maybe not necessarily a question you should know the exact answer to. I just want your opinion, or I just want a prediction. Again, I want you thinking about it and writing about it. You're not going to get scored wrong if your thinking isn't quite what I want it to be yet. That's the point of this activity. So you'll see some of these are the same questions that what I was talking before. Again, we're talking about unbiased, and I just really think this picture, I try and take a photo of it in class and then post it on the board and keep it up there for a while. Anytime we talk about bias sampling, I want you to have this picture in mind. So it's not just getting it wrong, but it's this consistent tendency to be wrong in one direction. And we won't always know. In this case, we could kind of think about why there is bias. We won't always know that. But I want you to think about, that's what we mean by bias. It's not just one sample, but it's this tendency to usually be off in the same way, right? A large majority of the time. So eventually we get to them suggesting a different way of selecting 10 words from the population that we think is more likely to give representative samples. And now we've talked a little bit more about what we mean by representative. Again, this idea of giving me a mini picture of the population, right? So what I learn in the sample is similar to what I learn in the population. So I'm going to ask you all to contribute on this one. What would be a different way of selecting 10 words from this population? Yeah, and you're exactly right. This was originally stolen from Ann Watkins and Dick Schaefer's Random Rectangles, but again, trying to make it a little bit more concrete. And one thing you'll notice, somebody who liked using it didn't necessarily like the Gettysburg Address. Students usually can still recognize it, but we have the ability to put in other passages as well. And so somebody asked for the lyrics to a Beyonce song. So if you'd rather switch over to that, you can. And then I just tried to make this font look a little bit more like old-fashioned writing, things like that. So systematic samples, so maybe taking every 5 words. If I only want 10, you'd have to think about, well, how many 268 divided by 10, so maybe every 26 words. But right now that might be a little hard to count those. Random number generator, what would I need to be able to use a random number generator? Or a frame, or a sampling frame, which is what? Yeah, I need a list that numbers all the words. And for some reason, my students don't understand the idea of a sampling frame that easily, I try and tell them, yeah, it's like a physical piece of paper. You would go to the registrar's office and you would get a list of every student at the school and you'd have to number them. And then you could go to a random number generator to select 10, 30, whatever. And then you have to go find them, right? And that's why a systematic sample or some other sampling methods might be a little bit better. But the key idea is that random number generation is what's selecting the words rather than any kind of human intuition or judgment. So maybe now we can go to the handout. This is a Google Docs version. So sometimes I give that to students if it's going to be a lab environment. This is before I went to the Jot form. One thing I meant to mention is we used to always do length of words. More recently, we've done whether it's a short word or not. We weren't sure that would still show bias, but it does. And so actually at this point of the course, I might still be working with proportions more than means. And just this idea of now I'm sampling from a population rather than all that one proportion stuff we did earlier in the course was really like sampling from a process. And they were thinking about coin tossing as modeling that random process, where now we're talking about this kind of concrete population. So again, you could kind of do both quantitative and categorical. And so some of this I switched. Some of this is still about proportions. Some of this is about means. And so I do usually, and again, sometimes this depends whether it's a lab day or a lecture day, but I think it might be worth a time for them to take a true random sample from the population. And I guess that's not in here. So I have a sampling frame. So I guess it's on the lecture notes page where they can open up this list of all 268 words that are numbered 1 to 268. And then they go to some kind of random number generator, which could be an applet, could be their phone. They generate 3-digit numbers. They go back and find those words. I do have them only do 5 this time for a couple of reasons. One's just saving a little bit of time, but I make them write out their words. Again, they record both variables, and then we make a class graph again, and then we're going to want to compare the results. So I do have those results for proportions. All right. So one of these is random samples, and one of these is the first way we did it, whatever you want to call those, haphazard samples or convenience samples. So which is which? Which is the bad sampling method and which is the random sampling of only 5 words rather than bad sampling of 10 words. Top is random, top is random. Why do you think the top is random? The dotted line is the parameter value. So when I switch over to a categorical variable, 41% of them in the population are considered short. So we'd like our distribution. Yeah, I guess if you realize dividing by 10 or dividing by 5 would allow you to tell the difference here. Any other features? Less bias, it's kind of balanced. What do you mean by that? And this is what I would torture my students the same way, just try and get them to be a little bit more specific, centered on the parameter value. So again, I have to tell you the parameter value, but once I tell you it's 0.41 and we realize that there's going to be a tendency to have too few short words, too small a proportion of short in our bad sampling method, and we would like our statistic to center around the parameter. And again, I want them to think of that in general, whether I'm talking about means or proportions, just really thinking about good sampling won't hit it exactly, and there might be a lot of variability, but our first goal is to center around the parameter value. And again, I try and put these on the same scale, and I try and keep these pictures accessible to them, right? Our top one is kind of our goal, and in which case I'll say the top one did better even with samples of size 5 rather than the bottom one, which had samples of size 10. So I'd rather have smaller random samples than a bias sampling method based on a larger sample. And what I wanted to say on the top, the other advantage of random sampling is I'm going to be able to estimate that standard deviation. I'm going to be able to say, I'm centered in the right place, and I think this is how far away it might be. Whereas as the bottom one, if we didn't know the parameter, we wouldn't know it's going to be centered. We wouldn't know how far away we expect to be from the parameter. And we'd like to do a little bit better estimates than that. And then what you'll see, now this was just day 9. Can somebody put in the chat the link to the 9 through 11 handout? Because I think we can finally look at that. And so this was day 9. So what I did this time is we did all of this together in class. And then there was maybe 10, 15 minutes left at the end. And this is the assignment that they got with their partner to be submitted 2 days later. And that's when they were going to go to the technology to do true random samples. So this applet is going to mimic exactly what they were just doing. And that's a thing that I also think is important is, we talk about, we have this ability to maybe think random samples are better, but we really should take a lot of random samples, not just 20 or 30 from our class. So now let's go over to technology to take lots of random samples. But hopefully they've done enough that they believe that the technology is doing what it's supposed to do. And so I want the technology to mimic what they did in that tactile simulation, if you will, as much as possible. So here's now our population data. There's our 4.295. There's our population size of 268. We can do sampling options. So for the random samples, and some of you are talking about, trying cluster and stratifying, they can explore that later. There's better examples for that, but they can do that. But I'm going to change the sample size to 5. I'm just going to do one sample. So let me put this in the chat in case you want to play along and you haven't found that link yet. So I'm going to just draw samples once. And so these blue dots, this is my way of trying to convince them they're coming from the population. And now I'm just looking at these blue dots. You can also do more of a vertical layout if that might, be easier for students to compare. I don't know. And then the blue is always representing the sample, and then this blue mean is that one sample's mean. Now, is everybody going to get the same sample mean when they do this? No, because it's random. Now, I'll admit the first time I tried to do this in R, everybody had the same random number seed, so we did all get the same sample. So I don't use R anymore for that, right? But this one, you should all get different ones. Or again, if students are kind of doing this on their own or with their partner, I just have them generate a few, right? Just to see that sample to sample variation. But this gray line here is the population, and so they can see how that's kind of centering around the population. And then once they kind of get an idea of that, then we maybe take a few more, and then we talk about, well, how many samples do I need? And so I talk about, well, when does this stop changing? When do you have a pretty good idea of what this distribution and sample means looks like? When does this mean, when does the standard deviation seem to be getting fairly steady? And again, my students have done some sampling already, some simulations, and so they're fairly comfortable with this, and they're probably happy to stop after 1,000 or 2,000. They can go all the way to 10,000 if they want. I can put any number in here. I like that ability to just kind of choose what number I want. They may want this to work out to a nice even number. I don't know how important that is, but I didn't quite make it, but maybe I can at least get to 1,100, right? And so then this is our distribution of sample means. And you'll notice I ask them a lot of questions about this distribution. So even though they've already done this for proportions, it's still worth some time to make sure they understand what's in this graph. In this particular applet, you can click on one of the dots over here, and that's the sample that gave me that really small sample mean. What does a sample look like that gives me a bigger sample mean, right? It can happen. It can happen that I happen to get, a bunch of words because it was only 5 words, but they all tended to be a little bit longer. That can happen even with random samples. But we still say this sampling method is better because the mean should be really close to that 4.295. So it's a little harder with averages because you're probably not going to hit 4.295 exactly. And we're here 4.29. You do want to kind of build that into students, that ability to say, this is pretty good, right? This is much better than that first thing we generated. It's going to change a little bit as I take more samples, but in general, I'm going to believe I'm going to try and make them believers, right? That random sampling is unbiased, meaning it's at least centered around the population mean. And so again, in these different handouts, and now I wanted this one. No, I didn't want that one, sorry. And this is where I put them all together. So we've kind of done day 9. They've had this assignment. One thing I do with these assignments now is I have them fill out the worksheet online, and I try and give them indications of here's where you need to write an answer, right? And that also just makes their answers in the same place for every student. So when I go to grade these, it's actually a little bit easier for me to kind of follow through what they're doing and get to the right spot. Or if I only want to grade some of the questions, I can find them a little bit faster. And just, yeah, they need to know what they're supposed to be doing. And I make them take screen captures of what they saw in the applet. Sorry, that's the problem with going to Google Docs is you'll lose your symbols, right? So we need to replace the symbols or teach them how to do that a little bit. And they make their distributions. And in this case, it's probably a reasonable time to introduce this formula. And I do it, we're just saying, see, this works, right? If you plug into this, you're going to get something awfully close to what you got in the applet, which I've now lost, right? So they should get something pretty close to 0.94 when they plug into that formula. And so I know I said, all right, let me move this over. I might not be introducing symbols at this point, but again, a few weeks in, maybe I have. And so, but they're probably going to want to know what sigma is, and you're going to want to spend some time on that. So going back to the applet, because this doesn't use symbols, make sure they know where that sigma is coming from and what they're using as n. And again, the big advice is talk a lot about number of samples versus sample size and which one is in this formula and which one's not, right? And that I'm going to close this one so I stop picking it. The number of samples isn't that important. We were just trying to get that distribution to see its long run pattern. What really matters is that sample size. And so then we have them make predictions like what's going to happen if I'm taking random samples, but now I go up to 10 like they were originally doing. And so again, maybe do a few at a time, then maybe do a whole bunch. And the point I want them to tell me. So remember, this is in that handout part. So they're going to do this first, and then I'm going to give them some feedback. So I want them to tell me that that mean hasn't really changed, the mean of my sample means, but that standard deviation has gotten a lot smaller. And then they can go back to that formula and think about why that's happening. And so that's how I introduce to them the impact of sample size. But again, really emphasizing that you need the random samples first, then you see how much money you have to get a larger sample size. And this explain here was highlighted in the doc version of this, the Word version of this, because I think I just said, you know, maybe focus just on the larger or smaller and not so much on the new value and what they would have predicted, things like that. Any questions before we do the next thing? I think you're sharing ideas more than questions right now, which is great. All right. Yeah, I do the same thing. I think it's not in here, but I give them all the symbols up here and then they just copy and paste them. Yeah. All right, so the next thing I have them do is think about the population size. And so you can change that over here on the left side of the applet where you can have 4 copies of the Gettysburg Address. And so if I do this times 4 and they actually kind of look through this list or they just look at this number, they can notice that now there's just, I guess it doesn't show up in this list, but it shows here. There's now 4 copies of the Gettysburg Address. But I want them to realize that the mean and standard deviation didn't change. So then I have them predict how that's going to impact the behavior of the sample means. And again, it's a prediction. And if you look at the JotForms version, one thing you can do there is you can say you have to type something here, and then you submit it, and then I'll ask you follow-up questions. So again, trying to keep them honest on that they're not just reading ahead or following along. There's some points where you can make them stop and think. The other thing you'll see in some of the labs I do is put a little stop sign and say, this is a really important question. Make sure you ask me, or I'm usually lucky enough to have a TA in the classroom with me at the same time. Ask one of us before you leave, right? And that's the other reason why that day 9, we do most of it together if I think they're going to need a lot more of my help. But then when they're just going to the technology, right, they can run those instructions on their own, and then they'll come back the next day and we'll talk about it. And that's why the actual assignment isn't due until 2 days later. So we have another class period in between where they can ask questions before they submit the final report. So hopefully you made your predictions about how changing and having 4 copies of the Gettysburg Address is going to change that distribution. I won't ask for them. I'll go ahead and do it. And another reason why you do want maybe a little bit more of a lab setting, because hopefully they've written some numbers down that they can compare to. All right, it doesn't have a great ability other than what you wrote down, but you should actually see there's not much change here. Right, I'm still centered around 4.3. I'm still getting a standard deviation around 0.67. That was only 1,000. Doing 10,000, right, doesn't really make a difference. Let's try that again. Let's do it again and see if we get the same results. So now let's do 100 copies of the Gettysburg Address. So now that's a huge population. Now the graph, unless they look at these counts, they can't really tell. So you really need to point them to that population size and convince them has the same mean and standard deviation, but now there's a lot more to sample from. So now I've got 26,800, and I'm going to take my puny little samples of size 10. Surely a sample size 10 can't tell me as much about this population. And then you draw your samples, and again, you see not much has changed. And then you can go back to that formula. That's why there's no population size in here. As long as that population size is big, it doesn't really matter. But again, this is a common misconception that I want students to at least try to figure out for themselves. This one takes 2 or 3 times before students believe me. So this is maybe the first time I've tried to convince them of that. But I think it's really important that at some point they need to struggle with that idea in an environment where they're not necessarily getting marked wrong, 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 but where they can try and explain their thinking and you can read their words. So I think that's what I'm looking for in these assignments, is the ability to get maybe not every single student, but at least pairs of students, maybe bigger groups, but I tend to do pairs, where they have to try that language and you have the ability to get individual feedback to different students, because they're going to be in a lot of different places in their understanding at this point. And again, the other point I was trying to make is if there's something in the course that you think they always struggle with a lot, right, that's what I want the exploration to focus on. That's what I want to really have them spend more time on struggling with. All right, so there was the ×4, the ×10, again, changing the sample size, again, thinking about that standard deviation formula. And then the other thing I used to do is, have these labs and have these lectures, and there wasn't maybe enough of a bridge between them. And I think it is still, even in a lab kind of handout, to give them something to read or give them something to recap or make a little wrap-up video to really make sure, these are the big ideas I wanted you to think about. So that was day 9. That was one day where they may not have gotten much of this in class, but they have 2 days to kind of think about it with a partner. And then in the lecture period, that's where we actually go through the literary digest as a famous example of some bad sampling, and we talk about sources of bias and things like that. So I cut that out for what I shared with you, but you can see it on the lecture notes page if you want. And again, some recap of some terminology, but in that context of, maybe an interesting question about the literary digest or the Gettysburg Address. Here's in this course where I transition to means and try to really think about, again, sample proportions, sample means. There's going to be a lot of similarities in how they behave. So trying to focus on the sampling variability and commonalities between different points in the course rather than them being these kind of individual silos with completely different formulas that aren't related to each other, right? So we think about how n's going to be in that denominator both times as well. And then here's another example. This is an example, so we're in that lecture period. So this is, again, maybe 5 or 10 minutes at the end of class, and they'll write their answers on a piece of paper and turn that in. And I'll look at that between classes and give them some feedback before they go to the next step. And that's something I'm mostly just grading it on, and they were there. We do enough of these that if they miss 1 or 2, it's not a huge thing. But again, it's just trying to give another opportunity for feedback before we go too far along, and just showing them some other applications and contexts. So birth weights, you can now get raw data of all births in the US. And so you can look at the population and you can think about how you might measure averages and what those would tell you, things like that. And sometimes I use this as, again, a data collection that takes no additional class time. So in the next day, we're going to talk about hours of sleep. And so I'm going to collect this data. I can type it in overnight, and then we're going to analyze it in class the next period. So let me pause there. Any questions on sampling or teaching about random sampling? One was to clarify, you're saying that a point of confusion is at the size of the sample, and then it went away. In relation, the size of population affects the ability of the sample to be informative. They will believe that for a long time. They'll think, oh, I only took 10% of the sample. That's not nearly as good as taking 20% of the sample, or a bigger sample, like sampling in Texas needs a much bigger sample than sampling in Rhode Island. So I do try and talk about that a fair number of times. Now, of course, there's a caveat, and I think that's what this one's getting into a little bit. That does assume the population is big compared to the size of the sample. So you do need to be a little careful with the Gettysburg Address, because there's only 268 words, and the Beyonce song was very similar. So that's nice because we can fit it all on the page. But if you start taking samples bigger than 20 or 30, that formula, that standard deviation formula, might not do such a good job anymore. And that's not a conversation I really want to have with my intro students, at least in week 3. So I try and kind of postpone that, or just make sure, in the real world, you're talking about all US births, or you're talking about all adult Americans. Those are going to be huge populations. In which case, once you get to 1,000 or 1,500, you're going to have a pretty small margin of error. I don't need to take 10,000. I don't need to take 1,000,000. And to be honest, I ask a question on my final exam every year that says, what kind of sample size do I need to estimate all 310 million US adults, or whatever that number is? And they will still gravitate to 1,000,000, right? Once you give them a big population size, they think you need a big sample size. And so I do try and talk about that a fair bit. I notice I don't think that you use the word uniform when talking about sampling words. I probably don't. I might talk about being skewed here, right? If I am going to do more with sampling, I do show them some different populations, and that's actually something I would, well, actually, we'll go to that in a minute. I want to show them that the population shape doesn't matter too much. I do get a little annoyed when they look at a distribution like this and say it's pretty uniform, because I want uniform to be flat, not just symmetric. So I might show them a uniform to kind of contrast that to bell-shaped, and why uniform or flat or even might not be it's not that they're bad, they just may not be recognized the same way by everybody, right? And just try and let them know why we use specific words sometimes and not others. I do talk about how a simple random sample gives every word an equally likely chance to be in the sample. And I will use that pretty early on, and sometimes even talk about 1 over n, or capital N, and how that might be a little bit different from, say, stratified sampling or cluster sampling. The main thing is you want to know what the probability is for particular words, and you don't want some, in this case words, some members of the population to have a higher probability than others. So we do talk about equally likely in that sense. Yeah, thank you for the question. Other questions I missed that didn't get answered yet? All right. Then let's talk about the next day. All right, so that's this day 11. So here's an example of where I give them some symbols that they can copy and paste. But yeah, Google Docs, you have to sometimes redo them. And so kind of what you saw before, how I like to give a lot of structure to that document that they're going to be turning in, and a lot of kind of signposts of exactly where I want answers. I took all the blank spaces out of the version I gave you, but normally there'd be a little bit more, and where I want their output when they're filling in a table. A lot of this, what I'm showing you here, Um, uh-oh, we're gonna go off screen. Is coming from this lab assignment. So this is what I used to do. We would be in a lab room in a computer room, and they would be on their own 95 to 100% of that day with a partner. And they have the permission to submit with a partner. And the way Canvas sometimes works, I make them join a lab group, and then only one person has to upload it. And then they get credit for it, and it gets graded that way. I've actually gotten really used to grading them online in Canvas. It pretty much turns everything into a PDF, and I can just write on it. And if you did work all the way through that jot form, the way I want to set them up is at the end, there's going to be a button that says review all your answers. And that's something they can print out or download if they want to keep a copy. Or I may even have them submit that into Canvas, because I think that'll be a little bit easier for me to grade than the spreadsheet, for a more in-depth type of assignment. And then you can also set it up so that gets emailed to you once they submit. So I used to do a system where they would email their responses, and I would get them throughout the day, and I would be able to answer them throughout the day. And instead of trying to do a bunch of these all at once, if it was a simple enough grading, I would just try and give them feedback right away. And then, doing a little bit at each day somehow is a little bit easier for me than trying to do them all at once sometimes. And then, yeah, once they review it, then they submit it, and I think they get a copy, or if they don't get it submitted, it'll send them a little reminder if they did that submit your email thing and say, do you want to finish this? So there's different ways for them to save their work, to access it later. What's nice, if they do save it, they see all the questions and all their answers. So again, they're all integrated, just like you saw before. And so before I did that, I always gave them either a Word file or Google Doc. Most of them on their own now, they just go to Google Doc, they know how to share that with each other, and they're good to go. And they're kind of simultaneously editing, which sometimes bothers me, because you will see some doing, I'll do A, I'll do B, whereas I might say, you're on the same machine, right? You only have one person typing, you have to talk to each other. I'm considering enforcing that a little bit. And so the only thing that was, well, there's one big limitation to this version, is they have to toggle over that Google Doc to answer their questions. And so that's why it's important to have the Google Doc kind of exactly mirror what they're seeing over here. And after they do 2 or 3 of these, they get used to kind of going back and forth. But in the very first lab, you'll see lots of reminders like, well, go to the Google Doc to do this, and then go back to the online lab to see further instructions, things like that. The main thing I liked about this version is the applet then gets built in right there, and you can get the instructions right there. And sometimes they'll scroll if you have more instructions. And again, they would just take screen captures of the applet output. So this is where they would be getting their class data that they submitted to me the day before. They would copy and paste that into the applet. I don't know, will this work? Yeah, so they can just highlight this and hit copy. There's new things going on with the applets now that we can talk about as well that make it a little bit easier to get the data in, but this is usually pretty good for them. And the other thing you'll notice in the labs is we do try and do the entire 6-step process all along. So I know I was talking when I went through these pages, but we talk about the introduction, we talk about the background, we talk about the research question, right? We talk about how the data were collected, any possible problems with collecting that data that way. If I have an 8 a.m. class, is this a good estimate of all Cal Poly sleep times, things like that. And then step 3 is to explore the data, right? So what's really nice about all the technology being integrated and then being used to doing more simulations is we can do all of that in one class period. They can get through most of this lab, which includes conclusions, right? And looking back and looking ahead. We can do all that in one class period, right? So this is just an applet of looking at their data, describing their data. By this point, they should be able to just write a paragraph in context, but maybe a little bit of help of what I'm looking for here. So developing those writing skills as well. Then one thing also you can do, and part of what I wanted to say is, I've tried a bunch of fancy things, but HTML is not so bad. I can put these numbers in, and then later pages will show these numbers. So again, that's a way to kind of carry information forward. Or you'll see in the jot form that once they answer some questions, new stuff appears, and then they don't have to kind of go back and forth to an applet or restart their applet. Hopefully they just go up a little bit on that same page. So again, trying to make sure information's there when they need it. And again, we can always improve all that, but those are the goals. And then we've also been trying to get them to say, what does a simulation involve a little bit more? So, okay, what am I hypothesizing about the population? What was my particular sample size? Statistic, am I dealing with a proportion? Am I dealing with a mean? You know, that's part of what we call the 3 S's to help them understand that simulation a little bit more. And then, yeah, so this populates with what I put in on that previous page. It steps them through the sampling. Here's where I start with a normal population. Maybe I can do this real quick. I did say I only had a sample size of 30, so we'll see how this goes. So we talk about this distribution. And then they go to another population and we talk about, oh, well, they could have looked like this. I don't know. We don't really know the population. That's why we're here. But then hopefully they notice that this distribution of sample means doesn't change that much when n is 30 or more, depending on the shape of the population. And so we've got 3 different populations here. So here's our even or uniform. And again, we tend to get that normal-ish looking distribution here. And again, putting them in an environment where they can tell you this versus you just giving them a theorem or a result without them really understanding what that is. I think these are the different populations. Then I might fill it in. Okay, let's get a little bit more technical here. Or this is what you can use carrying forward. Box it or something so they know it's kind of a key idea. And then they answer a few more questions. And again, just try and put them in that role of researcher or investigator as much as possible. Give them that ownership. This is one of the ones where it's their data, so they're interested in what conclusions they can make about themselves. And there's things that I do need to think carefully that I may need to make sure at some point in the course these things come up, but always kind of within a particular context. So non-sampling error we may not have talked about yet, but that's something I try and emphasize in this one. And even some lessons on how much sleep people need and thinking about how that is, and then just a summary of the different technology skills and the different statistical skills. And one thing I often tell them pretty early on is I don't really test you on the technology. It's just supposed to be a tool, right? But hopefully by now they're comfortable with this idea of sampling from a population. And then next we'll be looking again at different statistics and comparing groups, things like that. So that was the lab. So let me go back here, and while you're typing in questions, again, going back to that initial question. Well, now we know how to decide if the average human body temperature is 98.6. That's probably my favorite one quantitative variable because it has this nice number to compare to. Oh, well, I need to know about the distribution of sample means. Now I have a way of measuring whether a particular sample mean is far away from 98.6. I do use the sleep times. I tend to compare to 7 or less than 7. Ethan Allen was a boat in upper state New York that was putting too many people on the boat, at least once the tourists got really heavy. And so thinking about the average weight they were putting on the boat and whether that was larger than what the engineers had planned for. Backpack to body weight ratio might be another good quantitative variable that has a number you can compare to, although that one gets a little confusing when you start using proportions as your quantitative variable. That average water usage I mentioned before. And I would also show them some examples where quantitative data, the variability of the data is maybe the interesting research question. And then, as I say, I think it's really important that they're producing the data, or with the sampling that you're crowdsourcing that data so that's more meaningful to them, building something into the activity where they have to predict what's going to happen and then use the technology to quickly test it, because they're not going to change their way of thinking until you convince them that their way of thinking doesn't. They need to see that mismatch in their prediction, trying to get them to say things in their own words. Oh, if you do go to the jot form, which I may not be able to do quickly, I would love feedback on this little animation I put together. I don't really intend for it to be here, but maybe the start before the lab, where again, it just tries to summarize what was going on in that process. And I would probably be talking them through that. But again, the technology, the labs, those are one way of doing things. I think it's important to give them other visuals, other definitions, hit on those different modes of learning and thinking. So here I was just trying to say, we don't know much about the population and then what we can predict for the distribution of the sample means based on that. And then as far as designing the activity, and again, thinking about what is going to be something you're assessing them on versus what is maybe more of a teaching purpose and whether or not you're going to collect that information from them and where you want to give them feedback, that kind of thing. And I think my time is up, but I have a few more minutes if there's any other questions.
Thank you very much. Thanks everyone for being here. It is the top of the hour. If you need to leave, thanks for coming. Please come back next week, same time, same Zoom link. But if you have some time, Beth is willing to stick around and take some questions. There was a question from Hallie, or is it Haley, in the chat asking, do you make a big deal of the difference between random sample versus simple random sample? In other words, do you make a big deal of saying everyone has the same chance of being picked versus every subset of the same sample size has the same chance of being picked?
I think the true answer is when I talk, I really focus on the first one, but the definition I give them in their notes has the more complete response. And I probably do overemphasize simple random sampling, but I let them know that, real sampling isn't going to be simple random sampling. And we look a little bit at Gallup polls and a little bit at some of their language and terminology and how they describe it a little bit differently because it's not exactly a simple random sample. And that, what they report for the margin of error is going to be a little bit different when they adjust for different sampling techniques. But yeah, I mostly want them thinking about what I mean by random sampling is very different from, oh, I'm going to ask a few of my friends randomly, right? And so in this first intro class, that's what I'm really trying to emphasize. In my later classes, we'll go into more detail, but I want to get them over that other hump first. And then Brett asked if I try to incorporate random sampling into inference labs, like teaching two proportion inference and having individual student samples from a population data set. Yes, and I think you'll see examples of that from the later presentations. We do, again, in this intro course, tend to emphasize if you've got two columns, you just randomize the order of, say, the responses, and so they're redistributed to the explanatory variable. But I also have been using some applets more recently that show them two populations, show them two samples, show them a null distribution of the difference. And we do a lot of the same thing that you saw. And we kind of distinguish between simulating random sampling and simulating random assignment. But to be honest, that's more for my math majors or my second course in statistics than in my intro course. Again, I just want them thinking about how a p-value is just, could this have happened by random chance alone? And there's different ways to model that random chance, but that's the main reasoning I want them to have. And I want them to realize that that's the same, whether it's one proportion, one mean, two proportion, five means, right? I just want them to have that reasoning process.
We have a question from Ben about, is it important, is it helpful to have students take samples by hand before they go to computer simulation?
Yeah, so what I do here, and I think you saw it takes 2 days, day and a half, is I do have them do the bad sampling. And then, especially when I used to want them to know how to use a random number table, I would have them go through that process. So now they go to a random generation applet. But yeah, I do make them get 5 words and again, go up to the board, make a new graph on the same scale and compare those. But yeah, I probably just do that once. But I think having them do both methods and again, being part of that process is worth the half day that it takes. And
More
and
questions?
and we do that more. We've done that earlier in the course with the coin tossing and the tactile simulation. And definitely, yes, I think it's important to do a tactile before you send them to the computer, because the computer is still going to be a black box for many of the students. And so that's why, again, I want the computer to mimic what they did by hand as much as possible.
Feel free to unmute and ask a question if you don't want to type it in the chat.
I'm trying to make my inference labs be able to last longer due to students posting answers from my labs. I mean, I think some of that is if you use student collected data, like even the sleep time data, that's going to differ a little bit each term, right? You're usually going to be able to make a lot of the same points, but you can at least see different data. Now, sure, they're going to be able to copy over the words. They can get ChatGPT will now do a halfway decent job of giving them the right words, but usually you can tell that it's not their words, and usually by the time they get to an assessment, they'll realize that they're not able to do as good a job as somebody who did have that practice and putting it in their own words. Yeah, and then usually I do change some context a little bit. It's just hard. Like things like the Gettysburg Address just are so good. I haven't found anything, I want to mix things up a little bit. So yeah, I do. The other thing I do is after lab 1, I will post a model student lab and hope they read that before lab 2. So I do try and build in some ability to learn from previous labs, but just try not to do anything verbatim. And I guess I'll change 1 or 2 questions just to catch them, but hopefully they realize I'm paying attention enough to try it on their own.
More questions before we wrap it up here?
If you feel like you have time, could you talk about just briefly ways that you've streamlined your grading of the labs, just kind of how you approach that mechanically?
Um, I'm writing myself a note that something I'll add, except my pen's not working. So maybe email me too. Something I can put on with the lab 2 is the rubric that I have for lab 2. And most of these labs are about 25 points. Most questions are 1 or 2 points. Usually they get 0, 1, or 2 points per question. And so that's pretty quick to give them a check mark, so they know which ones I've read, or to just say you're not quite there. Sometimes they feel like these minus halves add up, but usually there is a good enough reason in my mind, and they get better. So yeah, so some of it is once I have decided how I want to grade it, which may take 1 or 2 times through, then it is pretty quick. So I can probably do 30 students in 2 hours, but maybe I'm making these numbers up, 5 students in that first hour, right? Getting it settled is what takes the longest time. But I do tend to grade them myself rather than give them to a grader because I do really want to emphasize the language. Now, the jot form, converting to that, I'm also going to convert more of the questions to multiple choice. So that'll be a little bit easier. Or if it's a longer lab, I may even tell them in advance, I'm only going to grade the last 5 questions. And some students will try and only go to the last 5 questions, and it usually doesn't work out so well for them. But, that's the other way to streamline it, is to pick the ones that are most important to you and only focus on those.
Thank you.
One more question if you have one. Maybe I'll stop recording here in case you have a question. You don't want to be recorded.
Oh, well, then I can admit this. The other thing I do sometimes do on the